In the previous lecture, we have discussed about the Boolean expression and Boolean function. We have seen the duality expression or the duality properties, and we have seen the canonical form. And little bit we have started the SOP or short form. From this lecture, we will start the details of SOP form. So, what is SOP form? So, in the digital electronics and Boolean algebra, there are two forms to represent any Boolean functions. First is SOP or sum of product form, and second is POS or product of sum form. So, first of all, this is sum of product form. So, what is SOP or sum of product form? The SOP or sum of product form is a method of simplifying the Boolean expression of logic gates. So, it's basically a method of simplifying any such Boolean expressions. So, in the short form of Boolean function representations, the variables are operated by AND dot product to form a product term, and all these product terms are added together to get the final functions. So, what is written here? To get any SOP or short form, the variables of any Boolean functions are operated by AND to form a product term, and the product term will be added or OR to get its final expressions. So, suppose let's take a function. Suppose f1 is a function, and its variables are a, b, and c. So, suppose this is a functions a, b, c bar plus a, b, c plus a bar, b, c. Suppose this is a Boolean functions. So, this is the variables of these functions a, b, and c. So, to get the SOP form, the variables a, b, and c are operated by AND. This is AND operations a dot b dot c bar. The variables are operated by AND to form this product term. So, this is a product term. These are the product term. This is a product term. This is a product term, and this is also a product term. And this product term will be added or OR together to get its final functions. So, this is product term, and this will be added to get its final term. So, this is sum of product form, sum of product term. That's why it is called SOP or sum of product form. So, now let's take an example. So, let's take f1 is equal to summation of m 3, 4, 6, 7. So, this is basically a SOP form representation in terms of min terms. So, what is this? This is a min terms. And what is min terms? We will discuss later. Now, so 3 can be written as 1, 1 in digital in binary form. So, 0, 1, 1. 4 can be written as 1, 0, 0. 6 can be written as 1, 1, 0, and 7 can be written as 1, 1, 1. Right? So, this is 0, 1, 1. That means 0 means its complemented value. So, we can write 0 as a bar. Suppose a, b, and c are the three variables of these functions. So, we can write 3 as a bar, b, c. We can write 4 as a, b bar, c bar. We can write 6 as a, b, c bar, and we can write 7 as a, b, c. Right? So, what is the function? So, f1 should be like that: a bar, b, c plus a, b bar, c bar plus a, b, c bar plus a, b, c. So, you can write this function in terms of SOP or sum of product form. And these are the product terms, and the whole functions should be in SOP or sum of product form, because only those output will be high. So, what is min terms? So, what is min terms? Min terms. So, min terms are basically such terms in which each variables are operated by AND with its true value or in complemented value. So these all are the minterms. So what is minterms? It's a term that contains each variables either in its true value or complemented value. So these all are the minterms. Let's see this A bar B C. In this term, the computed form of A is present here. The true value of B and C are present here. So this is a minterm. This is also a minterm. This is also a minterm, and this is also a minterm. So you can write F1 as summation of M 3, 4, 6, and 7. A means basically minterm. And for this output only, the output will be high. The output will be high. Output will be high for the minterms. So if we draw the truth table of these functions, we can see the output of only the minterms should be high, and the rest outputs will be 0 or low. So let's take another example. F1 is equal to AB plus B C bar plus C. So this is a basic form, and to make it its canonical form. So what is canonical form? You have to I have discussed it in previous video. What is canonical form? Canonical form means it consists each of the each variables which its true value or its complemented value. So here only A is present, C is missing, here A is missing, and here B is missing. So first we have to convert it to its canonical form, and then we have to make it SOP or sum of product form. So here C is missing, so AB into C plus C bar plus B C bar into A plus A bar plus C A into B plus B bar. So it's ABC plus AB C bar plus A B C bar plus A bar B C bar plus A B C plus A B bar C. So this is ABC plus ABC means ABC. ABC bar plus ABC means ABC bar plus A B bar C plus A bar B C bar. So this is canonical form of this Boolean functions. So what is its SOP form? So ABC means you can write it as 111. A B C bar means you can write it as 110. A B bar C means you can write it as 101, and A bar B C bar you can write it as 010. So this means 7. This is 7, and this is 6, and this is 5, and this is 2. So the function should be written as F1 is equal to summation of M 2, 5, 6, and 7. This is the SOP or sum of product form of this function. Now there are two types of minterms are available there. First is 1 minterm and second is 0 minterms. 1 minterm. 1 minterm means the minterms the minterms or the terms that contains each of the n variables that is present in this function, either in its true value or its complemented value. The minterms that gives outputs 1. So whatever we see after this is all the 1 minterms, because these minterms always gives the output as high, what are the 1 output. But there are another minterms that is called the 0 minterms. The minterms that gives the output 0 is called the 0 minterm. That gives output 0 is called the 0 minterm. So from the previous example, we can see here that summation of n 2, 5, 6, 7, which is equal to A4. So this is a 1 minterm because only 2, 5, 6, 7 inputs will give the high or output, and rest of the inputs will give the 0 or low output. So this is 1 minterm. So if we write this function and f1 is equal to summation of n 1, 3, 4, 1, 3, 4, then 0, 1, 3, 4, 0, 1, 3, 4, then we can see that this input 0, 1, 3, 4 will give the low output. So this is a 0 minterms. So in a function, how much minterm will be present, we can calculate it from its variables. Suppose two variables is present in a function f1, x and y. Two variables is present in a function. So its minterm should be 2 to the power 2 or is equal to 4. So 4 minterms are possible. In this function. So what are the 4 minterms? X, y, x bar y, x y bar, and x bar y bar. So minterm means each of the variables is present in the minterms, either in its true value or its complemented value. So if 2 variables is present in a function, then 4 minterms should be possible. If 3 variables is present, let's take this. If 3 variables is present, A, B, and C, then 3 or 8 minterms are possible to represent this function. So this is all about the minterms and SOP or standard product form. Now we will discuss the POS and max terms. So basically, so this is the general structure of any SOP or standard product form. So this is function if, and in the bracket list of variables of the functions of the function is equal to summation of m and list of 1 minterms. 1 minterms is basically called minterms because 0 minterms is not used in digital electronics. Instead of 0 minterms, max term is used in case of POS or product of standard form. We will discuss it later. So this is, suppose this is a truth table of any AND gate 0 0 0 1 1 0 1 1. This 3 will be 0 and this is 1. So only for these inputs the output will be high. So we can write this AND gate in case of sum of product form. So we can write it as if list of variables in these functions is this y, a and b. So y can be written as if of ab, the list of variables of the function is equal to, for this output input the output will be high, so we can write this as ab. So y can be written as f of ab is equal to summation of m3, because only for 3 0 1 2 3, only for 3 the output will be high. This is the SOP form of the AND gate. We can form SOP form in case of any gate correspondingly. So now we will discuss about the POS or product of sum form. So now this is product of sum or POS form. The POS form is exactly opposite of the SOP or sum of product form. So what is the POS form? The POS or product of sum form is a method of simplifying the Boolean expression. The SOP and POS both are the method of simplifying the Boolean expressions. But in case of POS form, all the variables are added to form its sum terms, and these terms are added together to get the final functions. In case of SOP form, we have seen that the variables are added to get the end terms, to get the product terms, and all the product terms will be added to get the sum of product form or the min terms, sum of min terms. But in case of POS form, the variables are added to get the sum terms and to get the max terms, and all the terms will be added to get its final functions or product of sum form. So here we will find the product of max terms, and those sum terms are called the max term. In case of SOP form, the product term is called the min terms, but in case of POS form, the sum terms is called the max terms. So suppose let's take an example. This is F1 A B C is equal to A plus B dot A plus C bar dot A bar plus B. So this is an example of any product of sum form. So here each variables are all added to get its sum form, and these terms are called the max term, and all the terms will be ANDed or multiplied to get its final product of sum output. So suppose for this, so what is max term? Max term is the term for which it consists all the variables that is present in the functions, either in its true value or it is complemented form. But in case of min terms, the variables are ANDed, but in case of max term, the variables are OR. So what is max term? Max term max term the terms where all the variables are present with or with each other and it is present in its true or complemented value. So you can see that a max term is defined as the product of n variables within a range 0 less than I less than 2 to the power n. So max term is denoted as the mi. So if I is equal to, suppose two variables present of a functions x and y, or I is equal to 2, then the possible max term of that function is equal to 2 to the power 2 means 4. If three variables present of a functions, then the possible max term is equal to 8. So in max term, each variable is complemented if its value is assigned to 1, and if its value is assigned to 0, then it's not complemented, it's true value. So if a variable, if in each term the value is assigned to 0, then it's called a true value in case of max term, and if it's assigned to value 1, then the variable is called the complemented variable. So there are two possible maxterm, that is one maxterm and second is zero maxterm. So one maxterm are the maxterms for those the function's output will be equal to 1, and zero maxterms are those maxterms for those the function's output will be equal to 0. So if we see the general structure of POS form, then we can see that if is a function, list of variables is equal to pi maxterm m pi m list of zero maxterm. So this is the general structure of POS form. A from list of variables is equal to pi m list of zero maxterm. Pi means here product of sum of each term. So let us see an example. F of A, B, C is equal to pi m 0, 1, 2, 3. Suppose this is a POS form. So that means for those outputs 0, for those inputs 0, 1, 2 and 3, the output will be 0, and otherwise rest of the inputs gives the output as 1. So this is POS form is completely opposite of the SOP form. So if we see its output, then we can see here that A, B, suppose this is two variables A, B, and this is output. So if here two variables present, so maximum of 2 divided by 2 means 4 output will be possible. 0, 0, 0, 1, 0, 1, 0, 1, 0, 1, 2. So for those 0, 1, 2, 0, 1 and 2, the output will be 0, and for this output, for this input, the output will be only 1. This is all about the maxterm. We can see here also that if f of x, y, two variables present of a function, then the possible maxterm will be x plus y bar, x bar plus y, and x bar plus y bar. So we can from this we can conclude that each canonical form can be expressed as the sum of minterms or the product of maxterms. You can see the canonical form in the previous lecture. So in canonical form can be expressed as the sum of minterms. You can see the minterms earlier, or the product of maxterms. So in this lecture we have seen the maxterm, minterm, SOP form and POS form. So from the next lecture we will go to the details of the keymap. We will see what is keymap, how the keymap is implemented, and we will see the details of the SOP and POS form, how the SOP and POS form implemented in the keymap. Thank you for watching.